Hi, everybody. I hope you had a really fun time talking about all of your great ideas for building or designing a ride that would use stored energy. So let's go ahead and see what Mystery Science is going to talk about in terms of stored energy and some ideas that they had.
The Twist-o-Matic might not seem like any kind of ride in real life, especially not one made from rubber bands, but there are actually amusement park rides that make use of elastic bands, like this, called the Slingshot Ride. And even though there's no spinning involved, what's happening in terms of energy is very similar. When you either pull back on a rubber band or when you twist a rubber band, like you did in the activity, the energy from your body gets stored in the rubber band. Or to be more exact, the energy from your arm muscles is getting stored in the rubber band. That's energy that came from the food you ate. When the rubber band is released, the stored energy gets released too, which is why your Twist-o-Matic would spin. But why did the thick rubber band spin faster than the thin rubber band, even though you gave them the same number of turns? We're hoping you noticed that the thick rubber band was a little harder to turn. Because you had to use more energy to turn it, that means more energy got stored in that rubber band. Which is also why when you released the rides, the thick rubber band spun around a lot faster compared to the thin rubber band. In other words, the more energy you put in, the more energy you get out. The more energy stored in something, the more energy it can release. If you did want the thin rubber band to go as fast as the thick one, then you had to store more energy in the thin one by turning it around more times. Again, because you added more energy, it released more energy. It spun around faster. Notice how there's a connection between energy and speed. The more energy you store in something, the faster it goes when that energy is released. Or to put it another way, if you want something to go really fast, you're going to need a lot of energy. And that makes sense with other things you've probably noticed before. For example, the faster a car goes, the more gasoline it uses. The faster an Olympic athlete wants to move, the more food they need to eat. What if we had used an even thicker rubber band in the Twist-o-Matic? Not one this thick, but one more like this. Well, let's have a look. Let's spin it up. It takes a lot of effort to spin this one. Whoa, you see this? Look at how much that thick one spins. If you liked using rubber bands as a way of exploring the connection between energy and speed, definitely check out some of the other activities you can try, which we've linked in the optional extras. Have fun and stay curious.